Okay, in continuation further reaction, I will explain electrophilic substitution reactions. So we can say electrophilic substitution reaction. So the first is say action of chlorine. This is called chlorination reaction. Chlorine on chlorobenzene. On chlorobenzene. So if we take, suppose say chlorobenzene and treat this chlorobenzene with chlorine in presence of ferric chloride, FeCl3. Ferric chloride is a what? Catalyst. Remember, ferric chloride is a catalyst. And this is what? Anhydrous. Anhydrous. Now here, I will explain to you how the reaction takes place. Cl with 2 electrons here shared. And that form chlorine, Cl2. So when it break, one of this will become Cl minus and one will become Cl1 plus. Because if the 2 electrons retain on one chlorine, then this chlorine become minus, and because this is without electron, therefore this will become plus. This is the electrophile. So that electrophile will go in ortho and para, and you will get therefore the 2 products over here, which will be like this. So please remember, I just shown here just to make you understand how there's a electrophile. So this is electrophile. I will call it as electrophile. Okay, so you will get here the 2 product, which will be ortho dichlorobenzene plus you will get also a product which will be para dichlorobenzene. Okay, and this is being symmetrical, therefore this is major. So see, symmetrical means it is symmetrical with respect to the position of electron here, and therefore the electron goes, the chlorine goes to this here faster, and hence this is found to be major. Always para is major. Remember, para is major. Para major. Alright. Suppose say this reaction carried out with anhydrous. Suppose say next reaction. If I just, so what it say here? Chlorination of chlorobenzene in presence of ferric chloride, which is anhydrous. Remember that it is anhydrous. Then you get what? Para dichlorobenzene. Para dichlorobenzene. Or you can also say like this: 1,4 dichlorobenzene. I think you, I don't know it. I should write okay. 1,4 dichlorobenzene. Okay. Suppose if it nitration, if it carried out, this is called chlorination. Nitration. If you carry out the nitration with nitrating mixture, what is it? Nitrating mixture, concentrated sulfuric acid and concentrated nitric acid. That is called as nitrating mixture. Okay, both concentrated. Okay, so concentrated. So mixture of concentrated nitric acid and concentrated sulfuric acid is called as nitrating mixture. So if I treat this with chlorobenzene with nitrating mixture, so chlorobenzene plus HNO3 in presence of concentrated sulfuric acid. Okay, this is also concentrated. Now remember again here how the reaction takes place. I will explain to you here. OH and O2. So remember that nitric acid can be written as OH NO2. So if this OH carry negative charge, this will be positive. Nitro group is positive. That becomes the electrophile. So NO2 group from here. So please see, check there. NO2 from here will go over here or over here. You got it? And now the remaining OH will combine with H and go out as water. And therefore, what will be the product you get here? See, this will become like this. Cl with NO2 plus Cl with NO2. Okay, Cl with NO2. Of course, the other product is water. Now the other product is not so important. So I'll just explain to you again what this I have shown here. Remember, nitric acid, I can write it as OH NO2. So when the reaction take place, this OH group over here and the H atom from here got as water. The remaining NO2, which is plus, that will become electrophile. That electrophile, because this position rich in electron, this also is rich in electron. Therefore, NO2 will either add here or here, but more is here, and therefore this is major. Again, remember here, this is major product. Okay, the name of this is what? 4-nitrochlorobenzene. 4-nitrochlorobenzene. I'll just write it properly so that you can see it, the name 4-nitrochlorobenzene. This will be what? 2-nitro, ortho. This is para. Alright. Suppose, so nitration if they ask, you must know that this. And this is what electrophilic substitution. Third reaction I can show, action of concentrated sulfuric acid alone. Concentrated H2SO4. Remember, sulfuric acid I can also write it as OH with SO3H. Okay. Now this SO3H is plus. This entire is what? Plus here. And this one is minus. So that's why this group is what? Electrophile. This is nucleophile. So H2SO4. You don't have to write that way, but I am explaining here how you get the product. See, now with that respect to that reaction, you can understand here what will be the product in this case also. So you will get here chlorobenzene plus, I can write here as OH with SO3H. Okay, this is with minus and this is what? Plus, or I can write, show it as H2SO4. Then what will get the product here as, easily you can understand what will go in the ortho and para position. So here there is chlorine. Now SO3H group will go here. So the reaction will go like this, SO3H. Now although I have shown the reaction here will be SO3 will be plus. It's better I'll write here so that why I showed here with S. So here also I can show this with a S plus. Okay. So this will be one product. The other product will be para, which will be SO3H. And here there is chlorine. Okay. And one more thing. See, sometimes students forget to write the bond. That is wrong. So please take care to show the bond. And one more thing, I will explain to you that. Now what is this? This is called, without this, this will be what here? Benzene sulfonic acid. If I show like this, this is what? Benzene sulfonic acid without chlorine. Now here I can say 2-chlorobenzene sulfonic acid. So 2-chlorobenzene, excuse me because I am writing here benzene sulfonic acid. And this will be called as 4-chloro. This is one word, chlorobenzene sulfonic acid. Now this is major. Remember, that is major, this is minor. Okay, remember you write this also major and minor. Major. Now you know that always para is the major and this is minor. I hope we can continue like this, understand that. Okay, so remember the reaction which are electrophilic substitution. Go to this all these things. And as I was just telling you, that I will show sometimes the student don't remember what mistake they make. Okay, this is major, remember I have written here minor, so understand that is major. Suppose you are writing that compound as like this. Sometimes you just write and you don't know you have made mistake. If I show like this is wrong. Remember what is the mistake that you make. The bonding between carbon and sulfur. See, the bonding is between carbon and sulfur. That's why different. Here we don't know where I have bonded. Oxygen also or hydrogen. That is wrong. So this is not the correct way of representing. So note that part very clearly about this representation. This is wrong. Okay, so I have mentioned in my word. So now remember that. Please see that you don't write like this. It should be what? Sulfur with this. Okay. So I hope we can understand all this reaction, and see, don't simply admire all this reaction what I am writing here. You please see that you all just practice. Unless you practice this reaction, you will not be in a position to understand very well. Okay, practice means write down again by your own, and see, you will become master of all this.